Section 5 of Histology of the Blood. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Peter Yearsley. Histology of the Blood by Paul Ehrlich and Adolf Lazarus. Translated by M. Myers. Section 5. The White Blood Corpuscles. The physiological importance of the white blood corpuscles is so many-sided that they form the most interesting chapter of the subject. That the white blood corpuscles play a significant part in the physiology and pathology of man has been recognized but slowly, obviously because there was at first some hesitancy in ascribing important functions to elements that are present in the blood in such relatively small numbers. A place in pathology was first assured to them by Virchow's discovery of leukemia. The interest in the question was increased by Cohnheim's discovery that inflammation and suppuration are due to an emigration of the white blood corpuscles, and these conditions were particularly suitable for throwing light on normal processes. The fact that in diffuse inflammations large quantities of pus are often produced in a short time, without the blood being thereby made poorer in leukocytes, that the opposite indeed occurs, necessitated the supposition that the source of the leukocytes must be extraordinarily productive. Hence, in contradistinction to the red blood corpuscles, their small number is fully compensated by their exceptional power of regeneration. Nevertheless, a considerable time elapsed before the powerful impulse that started from Cohnheim bore fruit for clinical histology. As we have mentioned, this was due to the circumstance that an exact differentiation of the various forms of leukocytes was very difficult with the methods in use up to that time. Although such distinguished observers as Wharton-Jones and Max Schultz had been able to distinguish different types of leukocytes, Cohnheim's work remained clinically fruitless, since the criteria they assigned were far too subtle for investigation at the bedside. Virchow, indeed, the discoverer of leukocytosis, interpreted it as an increase of the lymphocytes, whereas it is chiefly produced by the polynuclear cells. Only after the distinction was facilitated by the dry preparation and the use of stains did interest in the white corpuscles increase, and continue progressively to the present day. This is borne out by the exceptionally exhaustive hematological literature, and particularly by that of leukocytosis. In spite of these advances, a retrograde movement in the doctrine of the leukocytes has gained ground surprisingly, especially in the last few years. Ever since Virchow's description of the lymphocytes, observers have tried to separate the various forms of leukocytes one from another, and if possible to assign different places of origin to these different kinds. There now suddenly appears an endeavour to bring all the white blood corpuscles into one class, and to regard the different forms as different stages merely of the same kind of cells. The following sections will show that this tendency is unwarranted and unpractical. 1. Normal and pathological histology of the white blood corpuscles. The classification of the white corpuscles of normal human blood, drawn up by Ehrlich, has been accepted by most authors, and we therefore give a short summary of it, as founded on the dry specimen. 1. The lymphocytes. These are small cells, as a rule approximating in size to the red blood corpuscles. Their body is occupied by a large, round, homogeneously stained nucleus, centrally situated, whilst the protoplasm surrounds the nucleus as a concentric border. Between nucleus and protoplasm there is often found a narrow areola, which doubtless results from artificial retraction. Nucleus and protoplasm are basophil. Nevertheless, in many methods of staining, the protoplasm possesses a much stronger affinity for the basic stain than does the nucleus. The nucleus in these cases stands out as a bright spot from the deeply stained mass of protoplasm, which is reticulated in a peculiar manner. Within the nucleus are often to be found one or two nucleoli with a relatively thick and deeply stained membrane. With methylene blue and similar dyes, the protoplasm stains unequally, which is not to be considered as the expression of a granulation, as Ehrlich first assumed, but rather of a reticular structure. The contour of the lymphocyte is not quite smooth as a rule, at least in the larger forms, but is somewhat frayed, jagged, and uneven. Small portions of the peripheral substance may repeatedly bud off, especially in the large forms, and circulate in the blood as free elements. In stained specimens, especially from lymphatic leukemia, these forms, which completely resemble the protoplasm of the lymphocytes in their staining, may from their nature and origin be readily recognized. As far as the further metamorphosis of the nucleus is concerned, a sharp notching of the border of the nucleus may occasionally be found, the further fate of which is shown in the accompanying figure. It is evident that in this case the resulting nuclear forms are quite different from those which are characteristic of the polynuclear elements. The protoplasm possesses no special affinity for acid and neutral dyes, and hence in triacid and hematoxylin preparations, the small lymphocytes are seen chiefly as lightly stained nuclei, apparently free. In the larger cells, the protoplasm can be seen even in these preparations to be slightly stained. By the aid of the iodine-eosin method, the reaction of the protoplasm of the lymphocytes is shown to be strongly alkaline. They do not contain glycogen. These properties, taken as a whole, constitute a picture completely characteristic of the lymphocytes, and these elements can thereby be diagnosed and separated from other forms, even when their size varies. Generally speaking, these cells, as above mentioned, are distinguished in the blood of the healthy adult by their small size, approximating to that of the red blood corpuscles. In the blood of children, even in health, and in lymphatic leukemia, which are mistaken in various ways by unpracticed observers. Thus Troja's marrow cells still figure in the literature, but have absolutely nothing to do with the marrow. They are large lymphocytes, as was established by A. Frankel years afterwards. In the normal blood of adults, the number of the lymphocytes amounts to about 22 to 25% of the colourless elements. Increase of the lymphocytes alone occurs, but in comparison with that of the other forms, much more seldom, and will be conveniently called by the special names of lymphocytosis or lymphemia. 2. Sharply to be distinguished from the lymphocytes is the second group, the large mononuclear leukocytes. These are large cells about twice to 3 times the size of the erythrocytes. They possess a large oval nucleus, as a rule eccentrically situated, and staining feebly, and a relatively abundant protoplasm. The latter is free from granulations, feebly basophil, and in contrast to the protoplasm of the lymphocytes, stains less deeply than the nucleus. This group is present in normal blood in but small numbers, about 1%. They are separated from the lymphocytes because they are totally different in appearance, and because forms transitional between the two are not observed. It cannot yet be decided from which blood-producing organs these forms arise, whether from spleen or bone marrow, although there are many reasons for regarding the latter as their place of origin. These large mononuclear leukocytes change in the blood to the following kind. 3. The transitional forms. These resemble the preceding, but are distinguished therefrom by deep notchings of the nucleus, which often give it an hourglass shape. Further, by a somewhat greater affinity of the nucleus for stains, and by the presence of scanty neutrophil granulations in the protoplasm. The groups 2 and 3 comprise together about 2 to 4% of the white blood corpuscles. Footnote: in enumerating the blood corpuscles, 2 and 3 may be counted separately or in one group. End footnote. 4. The so-called polynuclear leukocytes. These arise in small part, as will be described later in detail, from the above-mentioned number 3 within the bloodstream. By far the largest part is produced fully formed in the bone marrow and emigrate to the blood. These cells are rather smaller than numbers 3 and 2 and are distinguished by the following peculiarities. Firstly, by a peculiar polymorphous form of nucleus, which gives the relatively long, irregularly bulged and indented nuclear rod the appearance of an S, Y, E or Z. The complete decomposition of this nuclear rod into 3 to 4 small round single nuclei may occur during life as a natural process. Ehrlich first discovered it in a case of hemorrhagic smallpox. It is frequently found in fresh exudations. Formerly, when various reagents, for instance acetic acid, were customarily used, the decomposition of the nucleus into several parts was more frequently observed, and Ehrlich for this reason chose the not wholly appropriate name polynuclear for this form of cell. As this name has now been universally adopted and misunderstandings cannot be expected, it is undoubtedly better to keep to it. The expression cells with polymorphous nuclei would be more accurate. The nucleus stains very deeply with all dyes. The protoplasm possesses a strong attraction for most metals.